A, it requires energy. And B, you're going from regions of lower into regions of higher. You're going upstream. Think of you swimming up a stream, right? You can't get in a raft and float upstream, can you? You got to paddle to go upstream. I need to apply energy to go against the concentration gradient. Therefore, you are actively transporting stuff uphill, which is what active transport's all about. It's a protein structure that will move stuff against the concentration gradient. And it will always cost you energy. It is, I won't say never. It's mostly costly. Let's look at a picture of what that is then. All right, so always get your bearings. You recognize this as a phospholipid bilayer, right? Phospholipids, cell membrane, hydrophobic, hydrophilic, polar things can't cross. What you need to understand, and might as well start memorizing it now, is that inside of a cell, so here's my cell. You're going to have inside high amounts of potassium compared to low amounts of potassium outside. Outside of a cell, you're going to have high amounts of sodium, and low amounts of sodium. Just memorize it now, because you're going to go over it and 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 use 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 it. Do you have a concentration gradient? Yeah, right? I have a difference in amount between one side and another. And they're polar, so they can't cross cell membranes. So high potassium inside, low potassium outside. High sodium outside, low sodium inside. Now there will be protein structures we'll talk about later. The sodium will facilitatedly diffuse into a cell, and there are channels for potassium to go out. If they keep doing this, they will reach an equilibrium, right? No net diffusion. And you always want to maintain this ratio of high potassium in, high sodium out. This is what makes most of your cells function, especially your nerves. So if I don't want to reach an equilibrium, I've got these little annoying sodium ions constantly dribbling into my cell, and potassium ions constantly dribbling out, I want to put them back where they came from. Well, high potassium inside, high sodium outside. This transporter is moving sodiums from inside the cell to outside. That's against the concentration gradient. At the same time, or in a 1-2 punch kind of a fashion, it'll also bring potassium where there's low amounts to where there's high amounts, and bring potassium in